Dear students, this is the continuation of slide number 20, video number 6. This is not a separate video, this is video number 6 only. Now, we are going to see the next compound, hydrochloric acid. Laboratory preparation. It is prepared by the action of sodium chloride and concentrated sulfuric acid. Equation NaCl, sodium chloride plus concentrated sulfuric acid is H2SO4, gives NaHSO4, sodium bisulfate plus HCl. And then this sodium bisulfate plus once again NaCl gives Na2SO4 plus HCl. So in all these cases we can prepare hydrogen chloride. So hydrochloric acid is prepared. Dry hydrochloric acid is obtained by passing this gas through sulfuric acid, because concentrated sulfuric acid absorbs all the water molecules. So we can get dry hydrogen chloride, that is hydrochloric acid. The next one, chemical properties. Chemical properties, like all acids, it liberates hydrogen gas from metals. Whenever an acid reacts with metal, it liberates hydrogen gas. See the first equation. Zinc plus 2HCl gives ZnCl2 plus H2. The next one, Mg plus 2HCl gives MgCl2 plus H2. And then sodium carbonate plus HCl gives hydrogen gas, NaCl plus CO2 plus H2. Then calcium carbonate, when reacts with HCl, it gives calcium chloride and carbon dioxide plus H2 gas. So in all these cases, hydrogen gas is liberated. The last one, sodium bicarbonate plus HCl gives NaCl plus CO2 plus water molecule. And then Na2SO4 plus HCl gives NaCl plus water plus SO2 gas. The next very important 3 more question, aqua regia. It is otherwise known as royal water. So how to prepare this royal water, that is aqua regia? 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid are mixed, and you are getting aqua regia. Aqua regia is used for dissolving gold. So gold is dissolved in aqua regia. Very important property. If you see that equations, one equation is written in the pen, which is very important, and combined equation. 2Au plus 3HNO3 plus 9HCl. So HNO3 is 3 parts and HCl is 9 parts. Therefore the ratio is 1:3. You should remember the ratio is always 1:3, con HNO3 con HCl. It gives auric chloride 2AuCl3 plus 3NOCl, nitrous chloride, then plus 6 water molecules, 6 H2O. So this is the main equation for aqua regia. Down, if you see the reactions which is given in the dissociation form, Au plus 4H plus NO3 plus Cl minus, which are all given in ionic form, you get AuCl4 plus NO plus 2H2O. Similarly for platinum Pt plus 8H plus 4NO3 plus 6ACl minus gives PtCl6 plus 4NO2 plus 4H2O. So this is the reaction for aqua regia, which dissolves gold and platinum. Very important reactions. And the next one is uses of hydrochloric acid. Hydrochloric acid is used for the manufacture of chlorine, ammonium chloride and glucose from cornstarch. It is also used in the extraction of glue from bone and also for purification of bone black. Purification of bone black. The next one, preparation of hydrogen halides. Hydrogen halides can be prepared from gaseous. Hydrogen halides are produced when water is added in drops to phosphorus trihalides, so PCl3, like that. So phosphorus trichloride. Here they have given X. X in the sense any halogen it can be. So equation is Px3, a common equation, plus 3 water molecules gives H3PO3, that is phosphorus acid, plus 3HX, that is hydrogen iodide or hydrogen chloride, something like that, hydrogen fluoride, any hydrogen halide. The next one, phosphorus plus 3x2 gives 2px3. So X you can have bromine or iodine. Px3 plus 3 water molecules gives H3PO3 plus 3HX. So X here is bromide or iodide. The next, from covalent hydrates. From covalent hydrates, how hydrogen halides are prepared. Just see the equation, H2S plus X2 halogen gives HX, hydrogen halide, HX plus sulfur. Here the hydrogen chloride is obtained as a byproduct, so we are getting sulfur. The next one, general properties of all the hydrogen halides. So bond dissociation enthalpy for HF it is given 562, it goes on decreasing. HCl it is 431, HBr it is 366, HI it is 299. The percentage of ionic character, if you see, 43, 17 and 113 and finally 7 for hydrogen iodide. Acidic properties, if you see, the equation HX plus water gives H3O plus, that is hydronium ion, plus X minus, any halide. Halide X is given as fluorine, chlorine, bromine and iodine. So any halide, chloride, bromide, iodide. So this is the equation for the acidic properties. The acidic properties, these solutions of hydrogen halides are acidic, known as hydrohalic acids. Hydrochloric, hydrobromic, hydroiodic acids are almost completely ionized and are therefore strong acids. But HF is a weak acid. You note this point. Hydrogen fluoride, HF is a weak acid, an objective type question. It comes often. HF is a weak acid, remember. And all the other acids are strong. Important point. And then next, see the equation, HF plus water molecules gives H3O plus fluoride ion, and then fluoride ion plus HF gives HF2 minus. The next, high concentration. The equilibrium involves removal of fluoride ions is important, since it affects the dissociation of hydrogen fluoride, increases hydrogen ion concentration. Several stable salts, NaHF2. See, this is another example for stable salts. NaHF2, KHF2, NH4HF2 are known. The other hydrogen halides do not form any hydrogen dihalides. The next one is itching property. Itching property means it corrodes glasses. That is why HF is not kept in glasses, which is known as a typical property of HF. They form salts with acids and bases and reacts with metals to give hydrogen. Moist hydrofluoric acid that is not dry rapidly react with silica and glass. That is why it is not kept in the glass bottle. HF. The equation is SiO2 plus 4HF gives Si4 F4 plus 2 water molecule is formed. So when it is stored in a glass bottle, it forms water molecule immediately. That is why we are not keeping in the glass bottle. Next, Na2SiO3 plus 6F gives Na2SiF6 plus 3 water molecule is formed. That is why HF is not kept in the glass bottle. This is otherwise known as etching property of HF. A very important question. And the next equation, Hi gives hydrogen ion plus iodine gas plus 2 electrons. It is readily oxidized to iodine. Hence, it is a reducing agent. A positive result is shown in the liberation of iodine, which gives a blue-black coloration with starch. What coloration? Blue-black coloration with starch. The next equation, hydrogen bromide is more difficult to oxidize than hydrogen iodide. HBr reduces slowly to H2SO4 into SO2, sulfur dioxide gas. See the equation. HBr plus sulfuric acid gives water, bromine and SO2 gas. Similarly, Hi plus sulfuric acid gives H2S gas, hydrogen sulfide, that is rotten egg smelled gas. H2S gas is what you call rotten egg smelled gas. And then properties. Reactivity of hydrogen decreases from fluorine to iodine. Stability decreases from HF to Hi. And then volatility, thermal stability, boiling point. HCl is less versus Hi is high. It increases. Acid strength also, it increases from HF to Hi. So these are all the varieties of properties of hydrogen halides. Please note it down. The next heading is interhalogen compounds. So what do you mean by interhalogen compounds? There is one sentence answer. Halogen combines with other halogens to form a series of compounds. So one halogen, that is chlorine, combines with fluorine, and fluorine combines with bromine, or chlorine combines with iodine. They form an interhalogen compound. So this is given in the table. There are 4 types they have given: AB type, AB3 type, and AB5 type, and AB7 type. Down some examples are also given. In AB7 type you have only one compound, that is IF7. In AB type you have so many: CLF, BRF, IF, BRCl, ICl and IBr. So these are all the examples for interhalogen compounds. This is the type of interhalogen compounds. The next, properties of interhalogen compounds. There are 5-6 properties are given. Please go through one by one. Let us see the first one. The central atom will be larger one. Among the 2 halogen, the central one will be the larger one, and other one will be smaller one. It can be formed only between 2 halogen, not more than 2 halogen. This is the property, main property. Fluorine cannot act as a central metal atom, being the smallest one. So among all the halogens, fluorine is the smallest one. Therefore, it cannot act as a central metal atom. Due to high electronegativity, with small size fluorine helps the central atom to attain its coordination number. It attains high coordination number. They can also undergo autoionization. See the example down. ICl, high plus, and high Cl2 minus. The next, high Cl3 gives ICl2 plus ICl4 minus. So this is the ionization equation. The next one is they are strong oxidizing agent. All the interhalogen compounds are strong oxidizing agents. So these are all the 6 properties of interhalogen compounds. So interhalogen compounds reacts with alkali. It reacts with the alkali and with larger halogens form oxyhalogens and smaller forms halide. Smaller one forms halide. Let us see one example down. BrF5 with an alkali, that is OH minus ion is given. It gives 5F minus plus BrO3 minus bromate ion. And similarly with iodine it gives hypoiodite ion. The next, structure of interhalogen compounds. So the structures depends upon the hybridization. See the hybridization, according to that the structure will be differing. The first one, AX type, the structure is linear, the hybridization is sp3. And the next, bond pairs and lone pairs are 1 and 3. And then T-shaped, AX3 is T-shaped, sp3 dehybridization, bonded pairs are 3 and lone pairs are 2. Then AX5 square pyramidal, shape is square pyramidal, the hybridization is sp3d2 hybridization when bonded pairs are 5 and lone pair is 1. Then finally AX7 pentagonal bipyramidal, the hybridization is sp3d3 hybridization, the bonded pairs are 7 and lone pairs are 0. So this is very important, where the structures can be coordinated with hybridization. So you must remember both structure and hybridization together. Then oxides of halogen. There are some oxides of halogen types are given. The oxidation state is also given from +1, +4, +5, +6, +7. The examples were also given there. You please go through. Oxyacids of halogen. Oxyacids of halogen, the types HOX, HXO2, HXO3, HXO4. The name is perhalic acid. So the common names are given: hypohalous acid, halous acid, halic acid and perhalic acid. The oxidation state of all these compounds are +1, +3, +5 and +7. Some of the examples of the compounds: for fluorine you have only hypohalous acid, HOF, whereas chlorine you get all types of acids. For bromine we get 3 types of acids. For iodine we get 3 types of acids. So all the acids are given in the tabular column. Let's see that one also. Next subheading is group 18, inert gases. The elements are known as inert gases. So what are they? They are neon, argon, krypton, xenon and radon. They all exist as gas. Their atomic numbers are neon 10, argon 18, krypton 36, xenon 54 and radon 86. We should remember all those things because it is very important. The next, see the next tabular column, the isotopes, atomic mass, electronic configuration, very important. That is, all will have octet structure S2P6, 2s2 2p6, 3s2 3p6, 4s2 4p6, like that. All the inert gases have completely filled 8 electrons in the outermost shell. Then atomic radius is also given, density, melting point and boiling points are given in the table. Just please go through that one also. The next one is chemical properties. Only xenon and krypton show some chemical reactivity. Xenon and krypton. Xenon fluorides are present by direct reaction of xenon and fluorine under different conditions of temperature and catalyst shown below. See the first equation, Xe plus F2 in the presence of nickel 400 degrees Celsius, XeF2 is formed. Similarly, Xe plus xenon plus 2F2, nickel plus acetone, the same 400 degrees Celsius, you get XeF4. The next one, 200 atmospheric pressure, we get XeF6. So these are all the different experimental conditions where we will be getting different products, but the reactants are same. Similarly, XeF6 is heated at 50 degrees Celsius in a sealed quartz vessel. It forms XeOF4. Down it is given. When the reaction is continued, the following reactions takes place. XeOF4 plus SiO2 gives XeO2F2 plus SiF6. So let us see all these equations one by one. And on hydrolysis with water vapor, XeF6 gives XeO3. XeF6 plus 3 water molecules gives XeO3 plus 6 HF. When XeF6 reacts with 2.5 molality of NaOH, sodium perxenate is obtained. Sodium perxenate. So sodium perxenate is Na4XeO6 is the formula. See the equation. And finally, super sodium perxenate is very much known for its strong oxidizing property. Na4XeO6 is a strong oxidizing agent. For example, it oxidizes manganese 2 oxide into permanganate, MnO4 minus. The equation is down there. 2Mn2 plus is changed into 2MnO4 minus. So this is the oxidizing property of sodium perxenate. And then structures of compounds of xenons are given. The compounds are XeF, XeF4, XeF6, XeOF2, XeOF4, XeO3. Then hybridizations are sp3d like this. And if you see the structures, you have linear structures, square planar, distorted octahedron, T-shaped, which you have already seen. It has a hybridization is sp3d, and then square pyramidal sp3d2 and pyramidal sp3. The example is XeO3, the final one. And finally, we have come to the uses of noble gases. The first one, helium. Helium and oxygen mixture is used by the divers in place of air oxygen mixture. One who goes into the water, that is deep sea divers. These divers use helium and oxygen gas mixture. This prevents painful, dangerous condition called bends. So helium and oxygen is a very good mixture for this. Second use, helium is used to provide inert atmosphere in electric arc welding metals. And then again, helium as lowest boiling point, hence it is also used in cryogenic, that is low temperature science, cryogenic engines of rocket, which can be used helium. It is also much less denser than air and hence used for filling air balloons. The next, neon uses. Neon is used in the advertisement neon sign, and brilliant red glow is used by passing electric current through neon gas under low pressure. Then uses of argon. Argon prevents oxidation of hot filament and prolongs the life in filament bulbs. Then krypton. Krypton is used in fluorescent bulbs, flash bulbs, etc. Lamps filled with krypton are used in the airports as approaching light, as they can penetrate through dense fog. Even in the bad conditions, weather conditions, these krypton filled bulbs or lights are used. The next, xenon. Xenon is used in the fluorescent bulbs, flash bulbs and lasers. Xenon emits an intense light in discharge tubes. Due to this, it is used in high-speed electronic flash bulbs and used by the photographers. And then finally, radon. Radon is a radioactive and is used as a source of gamma rays. Radon gas is sealed as small capsules and implanted in the body to destroy malignant cancer growth. So when inside the body, when you have a cancer growth, this radon is used for the treatment where it destroys the cancer particles. With that, this lesson is over. Then some of the assignments given. Give the uses of argon. What are interhalogen compounds? Then another important question is, what is aqua regia? So how will you prepare, and what is the proposition, and what is the use? So what are the uses of chlorine? Very important. And then very important process, what is Decon's process? So using Decon's process, what you are going to prepare? Let us see all these things in your assignment notebook. You please write it down in the notebook. With that, this lesson number 3 is over. Dear students, so far we have completed 6 lessons from volume 1 and only one lesson, 5th lesson, that is coordination compound, is pending. We will complete this coordination within a week before this November 15. Within 2 weeks I will complete the coordination compound. So be prepared, all the 6 lessons. It is very important. You don't waste the time. Always ready to face the exam. Thank you. Best wishes.